Okay, this is take 2 on my little, actually take 3, on my Models of Attention lecture. So this is just going to be a quick mini lecture on the 4 models of attention that we talked about in class on Friday. The one that I recorded in class, it's a little hard to hear, and it's just, I think it's better for me to just do it this way. Okay, so the first concept, the first idea that we talked about with regards to attention was the idea of attention being a mental capacity. So what I mean here is that we have a sort of a limited amount of mental effort that we can devote at any one time, and attention is sort of that limit of how much mental effort we have to devote to tasks. And we can see this mental effort being taxed in situations where we're trying to do more than one thing at a time. So in this example, we have a primary task, which in this case was a shadowing task where you had to repeat something out loud. And then another task where you had to listen to a separate channel. Don't worry about the details of that. The point is just that in this case, you're trying to do 2 things at once. You only have one source for your mental effort, and one task is using up most of the available capacity. I did a little demonstration in class of a task that taxes your mental resources called the NBAC task, but I'm going to skip over that for now. So the key idea here is that attention is limited in capacity. How much mental effort is how much attention is necessary for a given task. Some tasks require a lot of mental effort, others require very little, depending on how automatic those tasks are. And the idea is that you have one single source of mental resources. So a single capacity though, so this seems like it makes sense, right? But perhaps a single capacity doesn't fully explain what we observe in terms of people's ability to perform two tasks at the same time. So for example, we might have one person who's trying to pay attention to pictures while also paying attention to speech. And we might have another person who's trying to pay attention to 2 channels of speech at the same time. Which of those would be easier? Most of us would have the intuition that the first one would be easier. It's easier to listen to speech and look at pictures at the same time than it is to try to listen to 2 sources of speech. Now, if this is the case, this would suggest that if people had better performance on this task, this combination of tasks, that would suggest that perhaps these 2 types of tasks are pulling from separate sources of mental effort. And so in class, we did a little exercise where we kind of thought of a study that would test these 2 theories. And we'll have more practice with that kind of thing when we do the lab activity on Monday. What's important for you to understand right now is this idea of attention being a resource, a capacity, a resource for mental effort. And that one theory argues you have one source of mental effort, that's a single capacity. And another theory posits that you have multiple sources of mental effort, depending on what the task is. So you have a different source for visual tasks and a different source for auditory tasks, which means it's easier to do those things at the same time. If you're doing 2 auditory tasks, then you're pulling from the same source, and those things are going to be more difficult to do simultaneously. Okay, the next couple of theories that we're going to talk about, one is called the central bottleneck, and the other is attention as glue. So to illustrate the central bottleneck, let's go through the Stroop effect, which it might be familiar, and you will also, I think I have you doing a ZAPS lab of that for your assignment that's due on Wednesday. But on this next slide, I want you to look at the picture and identify the color of the text of each word. See how long it takes you to do that. Should be pretty simple, not too hard to do, okay? Now we're going to do the same thing again. You're probably finding this list much harder to identify the color of the text. And the reason for that is because your brain wants to read the word first and you get tripped up. And it causes you to take a second to read the word, then go back and get the color accurately, right? So the idea here is that when you're completing a Stroop task, your brain is doing two processes. It's reading the word and it's identifying the color. And the reading is automatic. Reading is something that is so, fundamental to all of our lives in the modern world. And it's become so automatic because we have so much practice with it that we can't turn it off. If we see a word, our brain automatically reads it and we can't turn it off. So what happens in the Stroop task is that because you have to read something first, you can't just ignore that or turn that off. It automatically happens, and it causes a delay in you actually identifying the color of the text. So the idea here of the central bottleneck is that it may be possible to perceive lots of inputs at the same time. Like you can perceive both the letters and the color of the letters at the same time, which would be an example of parallel processing, but you only select one response at a time. So you can only say one thing at a time. And since the reading happens automatically, your brain does that first, whether you like it or not, and you have to wait till that's done before you can do the next response, which is identifying the color of the word. So this would be an example of serial processing. So it seems we take in information in parallel, but then we respond in serial. Okay? And this is called the central bottleneck. The decision to make a response happens in serial, but it's called a bottleneck because you have all this information coming into the system, but then there's a bottleneck at the point of responding where only one thing can respond. You can only respond to one thing at a time, or you can only program one response at a time. So most theories of attention agree that this is a component of how attention works. So if we think about distracted driving, as you're driving along the road, you can perceive many, many things simultaneously. You can perceive the curve of the road and how fast you're going and how fast the car in front of you is going. And you can, take in something about the scenery around you, the colors of the trees, whatever it might be. You can pay attention to the radio that you're listening to, or maybe a friend who's talking to you in the car. You can be thinking thoughts about what happened that day or whatever. You can pay attention to lots of stuff simultaneously. But then when it comes to making your response, you can only make one response at a time, which is why if you're using a cell phone while you're driving, or if you're distracted in some way, that might prevent you from making an important driving response, like hitting the brakes or whatever it might be, swerving out of the way, etc. We'll talk more about that in class on Monday. Another possibility is this concept of attention as glue, and this is kind of where we started when I introduced the idea of attention back on Wednesday. So I'm going to skip this for now. Okay, so if you guys recall, when we were learning about vision and perception in the object recognition chapter, we talked about how initially it seems that we break up our visual input into multiple features. So we initially process color and shape and size and texture all separately. But then we have this important process of binding that takes place where we bind all that information back together so that we can form a representation of what we're looking at. We can actually perceive it. We can tell what it is and identify it, right? So with the idea of attention as glue is that attention is that mental process of binding everything back together, of gluing all the features back together. In the monkey business illusion, most of you already knew about this, so you noticed the gorilla, but you didn't know that the curtain was relevant in this particular video, and you didn't notice that it changed from red to yellow. Okay, your eyes got that information, sent it down the optic nerve, went into your visual cortex, got processed in some way, but you never bound it back together into something you could actually consciously perceive because you never had your attention on it. You didn't know the color of the curtain was relevant, so you didn't devote any mental energy to it, and you never bound those features of color back together so that you could identify that the color had changed. The example I talked about in class is with when you're driving. Motorcycles are dangerous for many reasons, but one of the important reasons is because other drivers in cars often don't notice motorcycles. And the reason for that is because they might not be accustomed to seeing motorcycles. It's not something they regularly are looking out for in the road. And when a motorcycle comes into their field of vision, because if they're paying attention to other things and they're not expecting a motorcycle, they might not put any attention onto it, and they might not even bind the features together to actually see it and witness it. So when an accident happens, oftentimes you'll hear the driver say, "I never saw him. I never saw that. I never saw the motorcycle." And it's because their brain, maybe their eyes saw it, but their brain didn't see it. They didn't perceive it in a conscious way. The other example we talked about in class was if you're witnessing a crime. If something is happening, a stressful situation, you're witnessing a crime, your attention might be on a wide variety of things, especially if there's a weapon in the room. Your attention might be drawn to the weapon, or it might be drawn to trying to find the exits, or whatever it might be. And even though the criminal's face might be available to you visually, unless you're paying attention to it, you won't ever see it in any kind of conscious way. And then after the fact, if you're asked to identify who was the criminal, you will be completely unreliable because you can't call up a memory for something that you never consciously perceived. So attention is crucial in sort of visual perception and in formation of memories for events. And we'll talk more about that in class on Monday. So I think that finishes it up. So in class on Monday, we are going to be doing a series of activities that are using these models of attention to kind of understand and make predictions about distracted driving behavior. And we're going to talk about how we can design studies to test each of these different models. So I recommend that you take a look in the textbook on the attention chapter. That will help you. There's nothing to actually prepare for Monday. There's no pre-lab because we will do it all in class as a group. And that's it. Hope this worked.